Hey, Ondra, it's great to see you and meet you on this podcast today. Thank you so much for giving your time to me, and I'm so excited to have you here.
Thank you, Vivek, and it's my pleasure to be here. You know, um, this is my favorite topic, and it's also my first podcast, so I'm extremely excited about the experience. Let's do it.
Absolutely. So, to listeners out there, me and Ondra connected, I think I would say a month ago, and we happen to have a common interest around software architecture. And I think, Ondra, thank you so much for taking this up and also being excited to talk about software architecture. I was so enthusiastically interested to listening to you when we last met and the type of inputs that you have, the opinions and ideas that you have on this topic. I think we should obviously go into details in the podcast today. But for everyone else who is curious why we are talking about software architecture, I think we will come to that topic in a moment. And I want to first start by asking you to briefly introduce yourself. Like, who are you? Where are you coming from? What's your story?
Thank you. So first of all, uh, my name is Ondřej Krajíček, totally unpronounceable. So I go by Ondra, and actually I prefer it. Even my customers are calling me Ondra, so I appreciate that. Uh, I was growing up in the generation where we were actually doing stuff with computers, not just playing computer games. And I'm sure you remember those times yourself. Like
Yeah, the good old
good old times, we
times.
were still, trying to write some code, and we were kind of curious about how that stuff really works, what it does. The games were not that compelling, so we still had this. I would say strong motivation to do something else besides just quote unquote playing. And I really, I actually I was growing up with the ambition to be a lawyer, like my father, and I think it was like fifth grade when I really realized that I want to do stuff with computers, and I completely switched my, I would say, ambition, my focus, and I was also lucky because back then. Uh, in the 90s in here in the Czech Republic. Um, one of the one of the best universities here in the country, called Masaryk University in Brno, established a completely new uh, department, or what we call faculty, uh, completely focused on computer science. And that's where I started in the 1999. And those were really like very uh, wild times, punk times, if you will, because I was lucky again, and I was able to be a student, an employee, and a teacher at that faculty, at that university back then, and I really appreciated that opportunity, and I stayed there until like 2007. I did some really interesting projects, finished my master's, not finished my PhD, and I still hold this regret that with the ambition to finish it one day, and then I switched, left academia, and went to business and joined a company called Vysoft, a Czech company, a startup which grew to be a global company operating worldwide these days. And I've been with Vysoft since then in technical positions, and then I transitioned temporarily. I took a temporary detour to business, working with our US team. And here I am working with Fortune 500 customers. Uh, I have driven our technology, working with our teams to deliver our products and services, working directly with customers on the largest implementations. Somehow, between the technology, product, and business, that's where I ideally find myself.
Fantastic. It's such an interesting journey that you had. And you mentioned about uh, when you were growing up, I think you mentioned that you had this plan to become a lawyer, if I got it
Yes.
right. Okay, how did like were you always interested in becoming a lawyer, or it was coming from your family? What was the story around
Oh, it
that?
was coming from my family, and but I think that what I really liked, and that's something I like about computer science and software engineering too. It actually requires a lot of I would say logic, and it's driven by principles, and it's uh, it's based on let's say like solid, profound structures. It's not a wild ride in a good way.
Yeah,
It is, of
yeah.
course. I think that we're all enjoying it very much, but it requires structured system thinking, and that's what I really liked, and that's why.
And Ondra, you mentioned about, I think in our private conversation, that you have been also teaching or in a teaching position. And I think that's where we connected around the topic of software architecture. How was that experience for yourself?
Well, yeah, that's why I said I was lucky when I joined the university, because I was not only a student, but I also had the opportunity to work there, which was also interesting, very interesting. But also to teach. Well, back then it worked in the way that students, like starting second, third grade, we were able to become tutors. So we were able to teach like seminars. You have these lectures, the courses, and then there are some accompanying seminars. So that's where I started. But little bit later, I also had a few courses on my own. I think that if I remember correctly, I was probably the first person in Brno teaching about Microsoft.NET and C# programming language and the fundamentals behind the common language runtime. But I was, teaching many things like functional programming and object-oriented programming, and I found this passion for teaching. I just love that. I think that the reason is that it's just it's a great experience first and foremost to see that you can actually have this meaningful exchange with people. Like they're listening to something you say, and then they ask questions, and it also helps you to actually learn better, because if you want to teach somebody something, you really need to know it very well. And I guarantee, and that's what I actually love about teaching the most, is that students, they usually come up with questions I would never come up with myself. So it gives you perspectives, and it gives you uh, things to consider, and things to learn. It's also very challenging, but in a good way. So for me, it's like if I really have to learn something, I prefer to teach it. Not that I just I'm not that person who is like two lessons ahead of the students. That's not what I mean. But still, like if I'm not sure about something, I want to confirm my understanding of something. Or I want to share something. Teaching is a great way how to do it.
Yeah, I think you said it in a right way. I think it also kind of aligns with the great Richard Feynman shared, right? If you really want to understand things deeply, you need to teach it. And uh, I think for me, a software practitioner, especially the topic that we're going to talk about today, I think the best professionals or people practicing software architecture are also people I know who have been phenomenal teachers. They really either they teach you by telling you things, or they teach you by showing you things, or directing you to things. And I totally agree. I think this experience of yours I'm obviously super interested to go deep into that on, how and what perspectives did it bring for you. But I'm so happy that you had that experience of going through the process of teaching at an early stage in your career. Do you what do you miss about uh, teaching software architecture or in general computer science that you cannot do at the moment?
I what I really miss, well, I would say the only thing I miss is focus, because I don't have as much time to work on that as I would love to. Uh, I have this let's say ambition or a goal to really build a good course uh, dedicated to software architecture, and I am teaching it at my alma mater, as we say here. But I'm having like 2-3 lectures a year, which is not nearly enough. It's a good start. I I extremely appreciate it. I'm really grateful to the people who are working with me at the university, who basically enabled me to have this experience even when I'm working in business and I'm no longer in academia. But I'm also sure that we have a good cooperation, and they are bringing their side of the story, and I'm bringing mine, and I can also share some experience from the trenches, if you will, and it's a great cooperation. So there are really visionary people at the university who understand the value of working with companies this way, um, having this mutual respect. That's something which we really had to build, the mutual respect, because most people in business, they don't really understand academia well enough so that they can be, let's say, good university lecturers, even when we are talking about guest lecturers. And at the same time, many people in academia, they don't understand business, and so there is this communication wall, which is really difficult to overcome. And I was lucky that I found people who just didn't have that. So there is one particular person which I wanted to mention here, and I hope you don't mind that, a lady called Bara Binova at the Masaryk University, who is a great partner in crime, working with me, and enabling me to teach the way how I teach, and I really appreciate that. So thank you, Bara.
Absolutely. It's so good to hear. I think this concept of mutual respect, and I'm glad that you raised this up because for me, I think you're in an interesting position having come from academia and then into the industry, into the business field. I'm quite curious to learn what are the things that you feel you gained to perhaps that shaped your perspective about doing business, about doing being in the software business. Some things that you picked up from academia that you feel really opened your eyes or brought new perspective in your time today with running a software business.
Well, I would say the first and foremost, and we already mentioned the teaching approach, because for me it's not only about uh, passion for teaching, but I also apply this structure or this model on software architecture itself, and I think that we will get to that a little bit later. And it also gave me the understanding of how important it is to understand the foundations, the historical context, for example, just to go a little bit beyond the obvious. Uh, there's not there there is there isn't always the time to do that, right? In business, we are driven by customer needs and deadlines, and the market pushes and disruptions. So it's extremely difficult to go a little bit beyond the obvious, but that's what I got from the academia, that it is even that actually makes it even more important to do that. And I would say way of thinking. People very often wonder. I don't know about about, for example, Western Europe, or I have a little bit experience from the US, but people often wonder if they really need college, university degree to do software stuff, be it, software engineering, or I don't know, program or product management, user experience, for example, whether that's really like necessary. I don't think it's necessary for learning the tools and the technologies and things like that. You can do that yourself, right? You don't need to go to college to do that. But what the good universities do is that they give you a way of thinking. They help you to realize your potential better, because they just show you that there is more than one angle, that there are some foundations which actually do not change, and that if you master them and if you understand them, you are future proof. And that's what the academia gave me, and I'm really grateful for that.
Yeah, I think this is super profound, because the point about forming the way of thinking is such an important part as we progress through, modern times, with new technologies coming in every single day, new frameworks, new tools, new languages. I think sometimes in the race of picking up these technologies, uh, we did not get opportunity to really reflect on how a certain technology or tool is shaping our thinking. And I think uh, by being able to, in your case, exposed to a university setup, what I hear is that you get a kind of way of thinking about things. Essentially, is putting and breaking down technology in its most simplest means, and then using that to really build up and understand anything. So I completely understand and rally with what you said. And I think what we are trying to also get to, obviously, in the modern times, is figure out a balance between how to create the time and opportunity for people who are getting into industry to really take the time and build that way of thinking, as you say, whether they have access to good universities or not, in any way possible, which also means listening to great podcasts, great conversations with people who have been in there. And I think that is also something which I'm quite interested in through this exercise today with you, is if you are able to open the minds of people who are listening to this conversation today, and for people who are either practicing software architecture or really thinking about this particular discipline or role or practice in a different way. So I'm glad that you centered our conversation today on foundation, the historical context which you just shared, and also the need to shape the way we think about things. And I'm hoping with this session, with this conversation today, we will be able to contribute towards that.
Yeah, and same here. I think that's a great ambition. So let's give it a try.
Absolutely. I think to get started, the foundation of everything is to be able to really define what we are going to talk about. So, Ondra, for you, if we have to put together a definition of software architecture, what comes to your mind? How do you express what is a software architecture to someone who may not have that understanding or view of this?
And you know that this is a trick question in a good way, right?
Absolutely. We start with a tricky
Yeah.
question.
Yes. And this is what even when I'm trying to explain this to the students, I'm always giving them like a heads up that there is no clear or good definition. And I think that there are two which I like. I learned to like, but they are not extremely helpful. But they are still cool. The best one I know is that software architecture is whatever gives you the answers to the most expensive questions around software. So it is not a structured definition, like it does not give you like a structure. Architecture is this, and that, but it's actually even better because it tells you what it does. So you can it actually gives you some guidance about what good architecture is, because good architecture means that it gives you gives you the answers to the right questions, to the right questions about what's expensive. And that's the tricky word, because expensive is not about, here in this context, expensive is not directly about money. We all know things like, you know, technical debt and how dangerous it is. But and this goes even further, because the price we pay is the energy, the focus first and foremost. And if we fail to have the right answers, or reasonably right answers, that means that we will have to pay a lot of energy and focus, and sacrifice a lot of energy and focus in the future fixing stuff. So architecture is just here to help us. It's a discipline that should help us to, I would say, make somehow reasonable, contextually the best choices we are able at a given point in time. Nothing is future-proof and nothing is perfect, but it doesn't have to be perfect. It needs to be good enough.
Yeah, I think there's so many valuable things you kind of packaged in that definition, and we can unpack that. I think one at a time. I think the idea about expensive questions, I think this is fascinating. For me, the other part which is quite interesting that you said was around not just the best of the best choices, but good enough. I think that's also a very powerful phrase that actually we can actually talk a lot more about what do we mean by good enough. And I think my favorite was the choices that are made at a given point in time, which is nothing is permanent. And this is such an important part, because a lot of times when we talk about software architecture, maybe in industry, in different systems and different scenarios, I think there is this understanding that architecture is forever, architecture is permanent, architecture is like written on stone. And I think we should basically spend some time on these three facets of it. So one on expensive questions, and what is that expensive question, as you said, and second part would be what's good enough, and the third would be at a given point in time. So for your perspective, Ondra, how do you see about defining these expensive questions, and what comes to your mind when you look at your experience addressing these expensive questions?
The bad news is that it comes a lot with experience. I should rather say with practice.
Yeah.
So I'm sure that many people just didn't want to hear this, because that's the bad news. You need to practice a lot, unfortunately, and I'm sure we all do. But there are some hints which you can find here and there, and which work very well. And before I mention some of them, I just want to say, please understand that I learned these things the hard way. So whatever I'm talking about today, I'm just sharing my mistakes. Okay, I just didn't find these things miraculously. They didn't fall from the sky in front of me. I learned them. I learned them by doing and by making mistakes myself. So the first thing is, I really appreciate these what I call A/B questions, and you do meet them every single day when building software stuff, like, what shall we do, this or that? And I think that there is a trick. There's always a trick, because what I think about these questions is that if you hit A or B situation, you're most likely falling into this trap that both choices are equally wrong. You just don't know it yet. And I've been there myself many times. So the good approach I like is if I end up in a B situation, I think that the right way how to address it, or at least the best way how to address it, is to take a step back and try to prevent the question from being asked. And rather than going for A to B, how can I even prevent myself from having to make that choice? How can I enable the customers or the operation people who are actually running the solution, maintaining the solution? How can I enable them to make the choice so that I make the software a little bit more flexible, a little bit more scalable? And that does not mean that I will grow the software from 20 configuration options to 20,000. That's not what this is about. But that wouldn't help anyone. But very often you can prevent a costly mistake just by giving yourself some maneuvering space. Like, instead of asking yourself, do I have to go with Mongo, or should I use CouchDB or something completely different? Then you can just by saying, okay, well, you know what if I can use anything and everything as long as it is just following some principles? Like, it's a data store, right? So why should I care about what is the backend? Maybe I can design the system in a way that there are like 50 different choices, not just 2 or 1 or 5, 50 different choices, and then I can enable those people who are in the field designing and delivering the solutions to the customers to make the right call under the circumstances. There is a very nice principle in Lean which addresses this. The principle is called to defer commitment, and that this really helps. This really helps to frame which questions should be answered and which questions should not. I would say that it's also indicated by your stakeholders. So the most expensive questions are usually not technical. Actually, it was one of the biggest surprises in my career was when I found out that the most important questions are not technical. The most important questions are about what are the real needs of the customers and of the stakeholders. What is actually hidden behind what they say? What is the priority? Which needs are more important than others? And are those going to stay? Are they temporary or are they somehow permanent? Is this a one-time thing they're asking for, and they will not need it 1 year down the road because they will completely change their for example, their business model or their way of working, and I'm just building on temporary stuff, or is this something which will stay? Those are tricky questions, and here what really helps is let's have an honest conversation with the people. And if you explain why do you need to understand the answers, and if and when you explain that this is not about like a written contract, that you are not going to hold them accountable for changing their mind in the future, they will usually give you honest answers. They will open up. They just nothing is set in stone, and I think that people are very often reluctant to just express the foundations, the reasons, the driving forces, because they are afraid that they will be held accountable for them in the future, and they are not always in control of everything.
That's actually a really interesting way of, explaining that. I What I get from you, Ondra, I think, especially about expensive questions, I think you are thinking in terms of the idea about lean decision making, which is, are we even in a state to make a decision between A and B, and does it even matter? I think this is a very powerful thought process, because sometimes we overlook that question because we are in a decision making spree. And I think sometimes the best decisions is not making that decision, which is also a decision in some ways, but you're not deciding between A and B, but really questioning why even we have to make that decision. Um, and I think you said something very interesting there, is to be able to allow the space to make that decision at a different level or at a different stage, whether it's operational or I call it people who are closer to the problem.
Yeah.
Say a little bit more about that, like by not being able to make a decision here between A or B and questioning whether we need to really make a decision, you're creating that space. And often the space allows other people to step in who may be perhaps closer to the problem or make a call which perhaps uh, would be the right decision at that point in time. How does that resonate with you, and what is your thinking about that?
Well, from my experience, it's all about customer intimacy. And as much as you can try, you can only do so much. So I always stood somewhere, between the customers and the internal teams, engineering teams, and I was always more on the, let's say, technical side. But I was able, and I really enjoyed having this close relationship with many customers, but not nearly enough. So one way how to address this for me is, I leave as many answers to the people who are much more intimate with the customers, the people in, sometimes those are business analysts. Different companies are using different titles and different structures, but it's always about, you listen to the customer, you understand what they need, and you fit your service or your product or both to what they are doing. And by not making some of those choices I was talking about, you're actually empowering them. You are enabling creativity. You're making their job more fun. So it's not just about flexibility of the solution itself. It's also about taking advantage of this vast customer intimacy that your organization has already with different people, and also giving them space so that they can enjoy their work a little bit more.
How do you see, Ondra? I would not call it criticism, but also some of the things that could go wrong here is when we are delaying decisions, potentially it can also lead to technical debt. It can lead to, as you give an example of, from moving from 10 lines of configuration to 100 lines of configuration. How do you counter that when delaying decisions and not making a bloated software, bloated product, which is trying to prevent making a lot of decisions by offloading it maybe through a configuration?
Well, this brings me uh, to the concept of replaceability, which is something I find really intriguing. But let's take a step back. I think that the right way is not, maybe isn't, it's not to say that we are delaying or deferring decisions. We are deferring commitments. So I just, I'm fine And that's probably a better way how to put this. I'm fine with making decisions, every single day, and most people are, right? But it's not about the decisions. It's more about commitments. It's about the small and big lock-ins we are suffering from on daily basis. So I think that the first thing is, by making a choice, how far am I committing? How far to the future? How far to the, let's say, to the foundations of what I do? How far am I committing ourselves into something specific, something which is really difficult to change? That's what I see. That's what I see there, and that brings me to replaceability. It's not about configuration. We've seen, I don't know, like 10-ish years ago, that was that convention over configuration pattern or approach, which gained popularity exactly for this reason, because we solved flexibility, or we addressed flexibility by introducing configuration options, and then we had thousands and thousands of configuration options, which also makes quality assurance much more fun, right? Because then you have so many combinations which you need to test on all levels. Just try to write a unit test on something which has like 100 different inputs. It's so much fun, and not all of them are obvious. There are lots of hidden things which are done by configuration, not by method parameters or whatever. So I think that replaceability, something which comes from Tom Gilp. Tom is actually the author of my second, I would say, second favorite definition of architecture, which is a little bit more structured, but I like it. He says that architecture is a servant of high priority stakeholder needs, is as small as possible and as simple as possible, but not simpler, and is replaceable. And usually, when I'm talking to students about this, they're usually completely confused. How can architecture be replaceable? That doesn't work that way. Like, and this is where the analogy with the architecture of buildings completely fails, right? Because the original concept of software architecture, and design patterns and these things, it comes from buildings. It comes from construction. And there's a lot of good analogy here, but this is where it fails, because software is still intangible. It's dynamic. It's fluid. It's not difficult to change. I'm usually comparing this when I'm, if you could see my lecture notes, you would see a picture of a pyramid there, pyramids in Giza. And I'm saying, okay, so this is an architecture, right? The problem is that it's not the same like software, because this one is not replaceable, and that's a good way, because it's there for thousands of years, and that's a good thing.
Yeah.
Because we can learn a little bit about our past, but with software it doesn't work that way. We can change something which is not tangible quite easily. So why wouldn't we? And that's what Tom is suggesting. I think if the change is so easy, why don't we design for it? So you ask me about how to mitigate the danger or the risk of too much flexibility, and I'm saying, okay, it's not. Let's not make everything configurable. Let's just change it, and let's rather focus on making that change as easy, as cheap in a good way, as possible. That's what this is about.
That's a really powerful way of putting it. And I think the idea that designing the system in such a way that making change easy and simple, and instead of thinking about deferring decision, you're deferring commitment, and you're not approaching it purely from a point of configuration. You're also thinking about concepts around replaceability. I think this is a really powerful way to put this all together. Let us come back to the last two parts of your definition. One was around good enough architecture, like not the best. Often you will encounter maybe customers or stakeholders will say, I need the best architecture. Or can you design the best architecture? And this concept about good enough architecture, and the other point is about at that point in time. How do you see these two parts together, especially about uh, the the comparison between making a best architecture choices with versus good enough, and the time element of that?
Okay, well, the simple answer to this is that this actually shows how important it is to make things replaceable, because that's the short answer. The slightly longer answer is that when I was 20, I just enjoyed building complex things. I loved that.
Yeah.
Just no level of complexity was good enough for me. I just wanted things to be complicated.
Why is that? Why did you love doing that?
I don't know. I think that it's just it's because you have so many options, right? You can build with that. This is what I like about software. You can do anything.
Yeah.
You can do an app which works for one user, and then you can just it's like magic, and then you can scale it up to 1 million,
Hmm.
and then every day you can go to sleep with the thought that somewhere out there are millions of people using something which you created.
Hmm.
And in my mind, that used to be connected with complexity. Well, then I realized that, and then when I hit 30, I realized that I actually like building simple things, because when I'm going to bed, I also want to sleep. Uh, I don't want to, I don't want to stare into, the ceiling, thinking about what if something goes wrong? What if it fails? It's 1 million disappointments is more than I can bear. So um, I realized that I also realized that building things uh, in a simple way and creating simple things is actually much more difficult,
Hmm.
and it is like infinitely more difficult. And I love challenge, so that's why I think that it was also the one of the drivers why I went from complexity to simplicity. I found it much more challenging, and there are many people saying this, right? Remember Steve Jobs when he was talking about Apple and their products, like the hardest question is to decide what not to do. Or out of I think that one of the most popular quotes about software and IT in general comes from Antoine de Saint-Exupéry, the author of Little Prince, who said that the perfection is achieved not when there is nothing to add, but when there is nothing to remove, and this is it. So that's the simplicity, uh, and uh, and I would say simplicity also means that you focus on your business logic, your business value, and then you can turn everything into commodity as the first step. Then you may realize, and that gives you a lot of ground, because there's a lot of commodity available these days. Infrastructure is a commodity, platforms are commodity. Even advanced technologies like machine learning is a commodity these days. Security to some extent is also a commodity. So there are things to reuse. So turn everything which can be turned into a commodity, uh, and focus on the business logic. And then at some point you can find that by taking some of those commodities and doing them yourself, you can gain a competitive advantage. So you can just bring them over from the commodity world to the competitive advantage world. But that needs to be deliberate decision driven by business, driven by what customers are asking for. It can't be an upfront admiration for something or upfront ambition that we can do it better, because I'm sure that many people can do it better than the mainstream, because mainstream is logically a lot about compromises, but we don't have time for it.
Yeah. So to get it right, what you're saying is thinking about, again, a definition. And we have spent a lot of time on definition, but I think it's good to spend some time on there. As you said, focusing on foundation and historical context is quite important. The good enough architecture and a given point in time, if you start approaching things around being replaceable, you can think about building an architecture that just works, but is designed to allow replaceability. And when I say replaceability, you don't have to address all the concerns. Think about where you can take advantage of a commodity. And when you see a differentiating factor of bringing or addressing that complexity by dealing with that commodity yourself instead of using a commodity, that would be a very deliberate decision coming from the business and customer intimacy.
Yes, I would say so. I mean, you can look at technical many technical choices, and you can say, okay, so how can I, if I'm going to do something, how can I enable myself to change it later easily? That is the question I'm asking myself a lot. And then you ask yourself, okay, what I'm going to change it for? And the right way how to address this is, I don't know. And I don't have to know, and I must not know, actually. I know that change will come, but I can't trouble myself with what I'm going to change it for, because the thing I'm going to change it for doesn't have to even exist these days. Now, many people are trying to think about specific things that will happen in the future. And I've been there myself, and I was like, okay, so we will use this thing here, and then in 5 years down the road we will change it for that, and it will be great. And that's not how it works. Really, design things for change, not for specific changes in the future, if that makes sense.
Design for change, but not a specific change. I think we can just use that as a tagline for this podcast.
Okay. That sounds good.
Yeah, I'm just taking a note of that. Design for a change and not a specific change. That's a very powerful line. Are you sure you have not done this before? You're
No.
good at it.
No. I'm just used to think out loud. Yeah, I just wanted to add one thing, for the technical geniuses out there. This all sounds very philosophical, but believe me, it's not. If you look at what we are doing today, like in the technology field, if you look at what DevOps is about, if you look at continuous integration, continuous delivery, if you look at things like containerization and serverless architectures, actually, all these things have one thing in common. They allow you, and they even kind of push you to design for change. That's what they are really about. So it's not that Docker is cool, so we are all using Docker containers for everything, or that serverless is so easy to create because you don't have to write so much boilerplate. That all those things are true. But the fun part is that they are actually going in the direction to prevent commitments. So, for example, I like serverless not because it allows me to write short functions which do stuff, but serverless architectures for me are about decoupling dispatch from the business logic. I can write my business logic, and I don't have to make any commitments about endpoints and communication protocols and application servers and application containers. There's no such thing. So it's actually, and that's the most important benefit for me, for example, is that if I don't want to concern myself about that stuff and I don't want to think about, okay, it's scalable today, how can I make it scalable tomorrow? It actually tells me, no, you don't have to care. And if tomorrow I realize that, Lambda is not scalable enough for me, or Azure functions are not scalable enough for me, I can just take, if designed properly, I can just take the whole stuff and I can wrap it up in microservices or something completely different. And this is what replaceability is. And all these tools and technologies are actually helping me to do it.
Right. Awesome. I really like how you kind of connected also the trends, also the evolving ideas around designing for change, designing for replaceability in mind. With that, I think we can now move on. So we talked about what is software architecture. We talked about the three interesting parts of the definition: answering to expensive questions, having a good enough decision, and at a particular point in time. And with that, I want to focus our conversation to like who practices software architecture. And I think maybe we take a step back, as you said, like we talked about definition, but I have often seen, and I think you've also seen, like today we have the roles called software architect, and there are topics and books about software architecture. So, what is your opinion about like practicing software architecture? Is it a role? Is it just a competency, or it's something else?
So I think that uh, we can approach this from the starting with the easy enough answer. So I think that we can easily agree that it's not a job title, even though it is in many teams, many companies. I don't think that architect is a job title. I've been there myself. I uh, I uh, I had architects in my teams in the past, uh, but I just believe that it's so misleading to call somebody, I mean by job title, to call somebody an architect, that I think it's a bad practice. The reason is very simple. If you call somebody an architect, you kind of, and that's the answer to your question, you kind of indicate that they are the ones doing the architecture, and that's not true. We all do. Even your customers are influencing the architecture. All the developers, all the engineers, all the stakeholders, we all do architecture. It's like security, of your apartment. Who does security of your apartment? Is it the person, the developer, the company who built the apartment? Is it you? Is it everyone? If I don't lock the door of my apartment and somebody robs me because I left the door open, who did the security of that? No, it was me, and I'm the user. So an architecture is the same. We all do software architecture, and I think it's dangerously misleading to call somebody an architect. I mean, in a job title. So that's one thing. And then you asked about roles and competencies. I think that architecture or software architect is a competency. Uh, it requires a way of thinking. It requires perspective. It requires understanding of lots of things. It requires some level of customer intimacy. We already talked about, and it requires, at least in my humble opinion, it requires one thing, and it's teaching. When I'm explaining this, I usually say, if there is one thing software architect should be, it's it's not the best developer in the group or the best, I don't know, designer in the group. It's teacher. It's a teacher. Um, and I'm also using the good teacher, bad teacher analogy, which comes from my elementary school years. When I liked most of my teachers, and but I only liked them when they were not giving the marks, when they were not evaluating us, and they had to, and they had to do that. from time to time, right? It's just
Yeah.
it's just a form of feedback. Feedback is important, by the way, here, because evaluation in this context is not about just saying you're not talented or you're not able to do this. It's just about feedback. Honest, direct, respectful feedback with underscore under honest and direct and respectful. So teacher, 80% you help, you support, you teach, you explain, you guide, you do stuff with people. You help them to understand the impact of what they are discussing, of the choices they need to make. Maybe you are even trying to prevent them from committing to things they don't have to commit to. Different commitments. We already discussed that. And 20% of the time, you are just what I call like quote unquote bad teacher. You're there to evaluate. You're not evaluating people. No, you're not evaluating their work. You evaluate your system, your product. This ideally is a data-driven discipline, data-driven exercise. You look at scalability, you look at security, you look at operational costs, operational effort. All those things exist because your stakeholders see them as important. Well, if no one cares about running costs, then okay, they are not important. But I dare say that in vast majority of situations, you do care about running costs. It doesn't mean that you have to pay them. In some cases, customers pay them. In some cases, you do pay them because you're running in the cloud and you're providing whatever you're providing as a service. But even if you're not paying them or your company is not paying them, you still have to take care of them. And that's the evaluation. That's the bad teacher, that you're basically making a strict, hard assessment. Is it good enough or not? We have measured stuff. And what do the numbers tell us? Are they improving? Are they declining? Are they good enough? Are they more than good enough? What does it tell us about what we need to change? What is the next big thing we need to look at? And that's what the architecture should do as part of the teaching job.
Right. So if I got it right, I think you look at software architecture as a competency, and I think let's not think about it as a role, or so not even role, but basically a title. And I totally agree with that. I think I have been in my own career journey in the position when I was called an architect, and I never understood that role and that job of what I have to do. And I think I felt more about empowering people and really helping them think about the process that they take to make a decision by themselves, and really helping them opening their eyes to it. So I like the idea about education and about being a teacher, because it's so much more about being in a position where you can help people to make a right decision or a good enough decision by providing them, but basically asking the right questions. And I really like the analogy around that, instead of also just giving them answers to something. And what I also liked in your response was this analogy about good and bad teachers. So what I hear from you is someone who is exercising the competency of software architecture has to play the role of a good and bad teacher. And bad teacher, in a sense, is all about measuring, tracking, looking for what worked, what did not work, and evaluation. But you're not evaluating people, you're evaluating systems, you're evaluating metrics, like from a data point of view, looking at how the system behaves. And I think that resonates from a point of, like, when we call someone who is doing software architecture, we never, I would say in my experience, I haven't seen people really thinking about in terms of the good and bad teacher methodology. It's more about giving directions to people, helping them unblock certain things and move on. But I really like how you also talked about measuring what you helped create. How has been your experience around, you know, leveraging software architecture as a competency in order to evaluate your systems? So what sort of evaluation you look at?
Well, data driven. Simply put, it needs to be data driven. And I think that your best friend here are the people who represent the customers or the stakeholders. So the metrics, the data I'm looking at are the data which articulate the value, the value as in value proposition of whatever you are creating. So those can be data which relate to really how expensive it is to run the system for one user, or for 10 users, for 1,000 users, and it's measurable, right? Uh, it's measurable on premise, it's measurable in the cloud, it's measurable on the edge. Uh, you just run it and you measure it in the worst case. Um, Things like latency, uh, round trip times, which actually directly impact user experience. You know, authentication takes 30 seconds, or authentication takes 1 second, or authentication is instantaneous. And then we can have the conversation about what's good enough. Like 2 seconds, okay, good enough. 10 seconds, no, that's too long. We don't have time to wait for 10 seconds. Like if every single authentication I do took 10 seconds, I probably would spend like an hour a day just authenticating. And you know, who wants that? You know, and I was really excited when I found out that there are customers out there who actually do care about these details. They are they are ready to have these conversations. So the data I'm talking about are really data coming from the customers, measuring the customer expectations, or I would say indicating the customer expectations. And you can have meaningful conversations. This is what I learned from Tom Gilp and his teachings, is that you can have meaningful conversations with the stakeholders and the customers, and you can frame these conversations in data, and you can express their expectations using the data, and then you can measure it. So that's where the data come from. Like, you know, the problem with data driven approach is that once you adopt the approach that things can and should be measured to give you insight, then the second step usually is for most people that they try to measure everything. Like, how many exceptions are in the log files? You know, or how many lines are in the log files? Oh, and what is the cyclomatic complexity of all the code? And how many changes are happening per sprint, and things like that. And then the next step in this is really to figure out which measurements are more important than others. And the easiest way how to do that is just talk to your stakeholders, talk to the customers. And this is where architect as a competency comes into play, because one of the most important components of that competency is that you can be the counterpart in these meaningful conversations, and that you can have that discussion in a meaningful way. And if anyone in your team can have that discussion, that means that everyone is an architect, and there's nothing wrong about that.
Yeah, totally. I want to now touch upon something that we spent, I would say, some time in our previous conversations, and I really enjoyed that talking about it, is around patterns. Uh, Often people who are getting started, they pick up a particular book or, style by looking at patterns, by looking at, oh, this is how I can solve something. And I've obviously enjoyed our conversation about it. And I would love to hear also you from now and share with all the listeners of the podcast is how has been your thinking about architecture patterns and how it's being used at the moment in industry?
Okay. I think that architectural patterns, not to be confused with design patterns, but architectural patterns are extremely dangerous. And the reason is that it's extremely difficult to capture the important context they exist in. And I would say almost like, I'm not saying it's impossible, but it's extremely difficult. I wanted to say almost impossible. And what I've seen a lot is that people usually fall into two categories. They don't have the enough experience yet to be able to apply patterns appropriately. That's the first group, and no amount of books can help them. And it's very dangerous for them, and kind of it's like, it feels like betrayal, because we are telling people, if you do this, it will be it's the right way, it's the right thing to do, it's the right way how to do it. And how can we know? We are not there with them. And then there's the second group of people who already have the experience, and then they don't need the architectural patterns because they already know how to do stuff and how to approach stuff, so they don't need the patterns. When we discussed this before, I was always a big enemy of architectural patterns, and one thing which I took from our discussion is that I actually found one way how to look at patterns, architectural patterns, which I like, and it's that architectural patterns are contracts with commodity. So we already talked about commodity, right? Like you isolate everything which is not your, let's say, core business logic driven by stakeholder needs, and you just turn that into commodity. You take this from Amazon, you take that from Microsoft, and there are so many options. But these things, they have to be built to be at least somehow universal. And I think that this is probably, for me, the only meaningful use for specific patterns, that they are kind of expressing how those things should be plugged in to your system. So for using commodity solutions, patterns are probably the only case where I would say, yeah, it's a good guidance. It's a good way how to say that. Like, and what actually brought me to this is that when I was discussing, I don't remember how long ago that happened. It was a long time ago. Like some of the patterns used in Kubernetes, and I really like some of the patterns used there. Most notably, Sidecar. That's my favorite. And why? Because it's another way how to actually make things replaceable. That's why. So that's why I like it. And I was like, okay, I hate patterns, but I like this one. What does that say about me? So I had to reconsider, and I realized, I like it because it's driving replaceability, and it's actually helping me to understand how should I use this commodity. That commodity being a service mesh topology, or Kubernetes cluster in general, or any kind of orchestration in general. And I find that meaningful. So in this context, I'm saying, okay, I'm perfectly fine with working with patterns, but just as a building block of a software application, of a software architecture, I don't think it's a good way how to do that, and I think it's dangerous. I'm a big fan of finding and following principles, and that's one of the taglines in my course notes is principles over patterns.
Yeah, I completely resonate with that, and I think the line round some patterns like the one that you talked about from the Kubernetes side drive replaceability. Hence, it makes that particular concern, which is around discoverability or just service mesh as a commodity. Um, I think it completely resonates to the point. Personally, personally, I also see, I think there's a value around thinking about patterns, but I think I totally see people falling into these buckets. As we're closing in to our last section, I want to bring to attention from your side, for people listening to this podcast, what are the things that you want to leave them with in terms of advice if they are starting with our playing on the competency of architecture? What should they think about? What should they consider?
Just judging from the mistakes I've made myself so far, I would say learn how to learn. One of the big mistakes I made in the past is that I didn't find enough time for learning, and I was not very efficient in it. I never stopped. I can say I never stopped, but I wasn't doing it enough. So focus on that. Also, I would say the big elephant in the room these days: no cloud will figure the architecture for you. I think that you see that yourself, right? That some people are saying, okay, we have cloud now, so we don't have to worry about architecture, we don't have to worry about security, because those smart guys in Microsoft and Amazon and Google and Rackspace and DigitalOcean, they figured that out for us, right? We don't have to think about that anymore. And I think that we all know that nothing can be further from the truth. So no cloud will figure it for us. And if you want to be an architect, be a teacher. Like, you don't have to be a teacher in a class. You can be a teacher to your friends, and that somehow, sometime you are teaching them and they are teaching you, and you can just build this community of practice in your company, and just exchanging talks and practical lessons, and just do stuff together, learning how to learn and learning how to teach these things, and it will come with practice. So practice is key.
So if I reiterate, so learn from mistakes, focus on that learning part, and I like that part about no cloud will figure out the architecture. You cannot outsource your architecture to a cloud provider. I like that. And lastly, I think it just resonates how we got started to this conversation is from your experience as a teacher. I think we have reached the end of this conversation, at least this part of our conversation. I really enjoyed talking to you, Ondra. I think I'm actually surprised that you told me that this is the first time you're doing a podcast, because you seemed very natural, and I think you had so many gems spread all over this podcast. And I thank you so much for coming in the podcast today.
And I thank you for the opportunity. It just feels good to share and pay at least something forward. And I really enjoyed the time we spent together talking about these things. So thank you very much.